For year 11, we're going to start a new topic today, trigonometry, and most of this will be revision. In fact, all of this will be revision from year 9 and 10. So start off with naming sides. We know the hypotenuse is the longest side. Okay, there we go, longest side, and the longest side is opposite the right angle. Now the opposite side in a right angle triangle is the side opposite the marked angle. The adjacent side is the side next to the marked angle. So here's my marked angle, and the side next to it is called the adjacent side. Now, we know there's three trigonometric ratios, sine, cosine, and tangent. Easy way to remember it is SOHCAHTOA. Sine is opposite over hypotenuse. It's the side opposite to theta divided by the hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. It's the side opposite to angle theta divided by the side adjacent to angle theta. So let's have a look at doing a question here. You can pause the video anytime and try the questions yourself. We'll start off with the first one. Now we've got to find sine alpha, tan alpha, and cos beta. So let's have a look. Sine alpha. Well, where's alpha? Here is alpha. So this is the opposite side to alpha, this is the adjacent side to alpha, and this is the hypotenuse. Okay, so sine alpha equals opposite over hypotenuse, which in this case will be 3 over 5. Tan alpha is opposite divided by adjacent, which will be 3 over 4. Now, what about cos beta? Cos beta is different because you're going to have to change the labels of the sides. Now, because we're talking about this angle this time, now this side now will be the opposite side, and this side now will be the adjacent side. Okay, so cos beta is the adjacent side divided by the hypotenuse. So that'll be cos of beta is 3 over 5. Okay, next question. So sine theta equals 2 over 7. Find the exact ratios of cos theta, tan theta, and sine theta. Now, sine theta is equal to 2 over 7. Sine is opposite divided by hypotenuse. So I can draw a right angle triangle and I'll label one angle theta. There it is, theta. The opposite side is 2, hypotenuse is 7. Now that means we've got to work out what the adjacent side is, okay? We're using Pythagoras. Pythagoras says a squared plus b squared equals c squared. So it's going to give me, let's call the unknown side a squared. All right, so let's just say this is a, this is b, and this is c. So you're going to have a squared plus 2 squared equals 7 squared. That gives you a squared equals 7 squared minus 2 squared. Okay, so you're going to have a squared is equal to 49 minus 4, which is 45. And that gives me, I'm going to just put a plug in here, running out of electricity. Okay, there we go. All right, so that gives me a squared is 45, so a is root 45. Okay, so a is equal to the square root of 45, which we can change using surds. Okay, that's going to be root 9 times root 5, which is just 3 root 5. Okay, so that means we can come over here, update this side. This side is 3 root 5. Okay, we'll just rub out the other sides. There we go. All right, now, for that angle theta, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So if we want to find out what cos theta is now, cos theta is adjacent divided by hypotenuse, which is equal to 3 root 5 on 7. 3 root 5 on 7. Now, what about tan theta? Tan theta. Tan theta is just opposite over adjacent. So just write that down, opposite. Opposite divided by adjacent, which will be 2 over 3 root 5. Okay. Sine theta, well, actually, that's a mistake. We don't need that because we already found it. Sine theta is 2 over 7. Okay, next question. How about trig ratios on the calculator? Well, last year you would have learned that 1 degree is 60 minutes. So you can divide 1 degree up into 60 smaller pieces, and 1 minute is 60 seconds. So you can divide 1 minute up into 60 smaller pieces called seconds. So, for example, this 12 degrees, 15 minutes and 32 seconds is how this reads here. All right. Now, rounding to the nearest degree, 12 degrees, 15 minutes and 32 seconds would be 12 degrees to the nearest degree. Okay, because we round up if it's 30 or more. So if you look at the minutes here, that's not 30 or more, so this stays as 12. Over here, we've got 37 degrees, 30 minutes and 18 seconds. That rounds to 38 degrees because the minutes is 30 or more. And 53 degrees, 35 minutes and 12 seconds rounds to 54 degrees because this minutes here is 30 or more, so we round up to the next degree. Rounding to the nearest minute, again, we round up if the seconds are 30 or more. So rounding to the nearest minute, well, here are degrees, minutes and seconds. So look at the minutes. Is that 30 or more? It's not, so it stays as 15. So 12 degrees and 15 minutes to the nearest minute. And then have a look at the seconds here. Seconds are 30 or more. So we round up the minutes to the next one, which is 26. So the answer is 53 degrees, 26 minutes. All right, have a go at these questions now using the degrees, minutes, and seconds. Okay, so you'll need your calculator for this. So find cos of 58 degrees, 19 minutes. All right, so on your calculator, whoops, yeah, let's try and grab this. Move it. All right, hang on. Move. All right, so I want to move this over here. It's better. Okay, so we're going to go cosine 58 degrees, 58 degrees, then 19 minutes, 19 minutes, close bracket, equals. So you got 0.525 to 3 decimal places. So let's fix it up. 0.525. You can pause the video at any time and try these. 0.525 to 3 decimal places. Let's try the next one. So this time we will have 38 degrees, 14 minutes. So sine, press sine, 38 degrees, 14 minutes equals to 3 decimal places, 0.619. Okay, so let's write that down. 0.619. Okay, here we go. 0.619. Okay, now let's look at the next one. So actually I'll do number 4 first, so I don't have to move my calculator. So we've got to find theta in degrees, minutes and seconds here. So what I'm going to do is press shift, inverse cosine, okay, which is here. Then 0.0675, close bracket. And I've got to convert it to degrees, minutes, and seconds. So I press the degrees, minutes, seconds button there. That switches between decimal and degrees mode. So that's 86 degrees, 7 minutes, and 47 seconds. 86 degrees, 7 minutes, 47 seconds. Okay, 86 degrees, 7 minutes, 47 seconds. 7 minutes, 47 seconds. There we go. All right, so the buttons we press, I'd write them down. You have to press Shift on your calculator. Then you have to press the inverse cosine button. Right, then you have to press 0.0675. You have to close the bracket. Then you have to press equals. Then you have to press the degrees, minutes, second button. Okay, let's try the sine one now. Okay, so we're going to go Shift, sine inverse, 0.348 equals. That gives you the angle. Press the degrees, minutes, seconds button. 20 degrees, 21 minutes, 54 seconds. Okay, so 20 degrees, 21 minutes, 54 seconds. There we go. Done. Oh, that wasn't a sine. That's a mistake. It's meant to be tan. Right, let me fix that up. So Shift, tan, 0.348 equals. And then degrees, minutes, seconds button. 19 degrees, 11 minutes, 17 seconds. Okay. 19 degrees, 11 minutes, and 17 seconds is what we got there. So 19 degrees, 11 minutes, 17 seconds. Okay. So doing that one again. Shift, tan, 0.348. Okay. Now, why do we round up to 17 seconds? Is because 16.43 is actually should be 16 seconds, not 17 seconds. 16.43 minutes. That should be 16 there. Okay. 16. All right, let's just double check the other one. Make sure I got that one right. Move. Okay, so Shift, cosine, 0.0675, close bracket, equals 87 degrees, 7 minutes, 47. Yeah, that's correct because that's past the 0.5 mark. That's okay. All right, so let's move on. Let's do some right angle triangle problems. So for here, we're going to find the missing side. So let's have a look. Now, here's our angle that we're working with. So this is the opposite adjacent hypotenuse. Now you can see that we're given the hypotenuse and we've got to find the adjacent sides. The two sides we're working with is adjacent and hypotenuse. So that means I'm going to write my cosine formula down. Cos theta is A over H. So that gives me cosine of 23 degrees, 49 minutes is equal to the adjacent side, x divided by 11.8. Okay, now to get the x by itself, I'm going to have to multiply both sides by 11.8 times by 11.8. So it's going to give me, well, this will cancel here. So it gives me x on that side. So you're going to get 11.8 multiplied by cosine 23 degrees, 49 minutes equals. So to 1 decimal place, 10.8 centimetres. Now on your calculator, how do you do that? You are going to do it like this. I'll just move it. Okay, so you're going to put in 11.8 multiplied by cosine 23 degrees, 49 minutes, close bracket, equals. There you go, 10.8 to 1 decimal place. Okay, next question. Find the value of y corrected 3 given figures. Okay, so what angle are we given? Here it is. This is our angle. All right, this is the opposite side. This is a hypotenuse. This is the adjacent. Now you're given the opposite side, and you've got to find the hypotenuse. So that means we're working with sine. Sine theta equals opposite divided by hypotenuse. So that's going to give me sine 41 degrees, 15 minutes equals opposite is 9.7 divided by y. Now, what we're going to do is make y the subject of the formula. The easiest way when you've got y on the denominator is to swap all of y with all of sine. So these guys swap over. So you're going to get y is equal to 9.7 divided by sine 41 degrees, 15 minutes. Now put that into your calculator, 9.7 over sine 41 degrees, 15 minutes, and you're going to get 14.7, and that'll be meters. Okay. All right, question 3, finding an angle in degrees and minutes. Let's have a look. So here we go. We've got the adjacent side here, the opposite side here, the hypotenuse here. You're working with a hypotenuse and adjacent, that's cosine. So you're going to write down cosine of theta equals adjacent divided by hypotenuse. So cosine of theta is equal to 5.8 on 7.3. So theta will be the inverse cosine of 5.8 on 7.3, which equals, okay, so shift cosine 5.8 on 7.3, close bracket, equals degrees, minutes, seconds button, 37 degrees, 23 minutes. 37 degrees, 23 minutes, which is this one up here. Okay. Right, next question. Find the value of alpha to the nearest minute. So we have, here's our angle. This is the opposite side, this is the adjacent. This is a hypotenuse. So we're given the opposite, given the adjacent, so we're working with tan. So tan alpha in this case is opposite divided by adjacent. So tan alpha is equal to 4.9 on 2.1. So alpha is equal to the inverse tan 4.9 on 2.1. So putting that into your calculator, shift tan, or shift inverse tan 4.9 on 2.1. And press the degrees, minutes, seconds button, 66 degrees, 48 minutes. Okay, now just those calculator steps here. Let's have a look at the calculator steps. You're going to go shift tan, I'm going to go 4.9 and just use the divide by button, that's easiest, 2.1 brackets equals, and then degrees, minutes, seconds.